All right. Hello, good morning, Prince, Victor, Trisha, and Neo. And for those who will be just watching the recording, um, we are already in week number 12, so almost patapos na yung SEM. Just to lay down the plan for the rest of the semesters, I think I mentioned in the email that I have two topics left: the Morozov discrepancy principle and the singular value decomposition. All right. I was working on the Morozov since last night, I discovered some problems, and I'll talk about it later. I don't know if it will be good news to you or it will be bad, but I'll just leave it for later. But definitely we'll talk about singular value decompositions, and I think we can cut the class there because there's a lot of other regularization techniques, but I don't think Number one, I don't think we have the time to finish them off. The second one, we might not have the technical capabilities to discuss them right now because the prerequisites in Math 191 is very relaxed. So we need a lot of functional analysis, a lot of real analysis, some bit of optimization to really talk in details about these regularization techniques. And I don't want to overburden you guys with all of those technical background that you need to know. That will be quite unfair kasi hindi ko naman kayo required to have that background or that much of a background before enrolling in this course. So if you'll need them, if you will need them in your thesis, in your special problem, I'll be happy to help you, even though I am not your advisor. So you can consult with me later if you realized in your research projects, kailangan ko ng regularization. Kaya lang hindi gumana yung L-curve at saka yung singular value decomposition na diniscuss natin sa klase. So if you need fancier regularization techniques, you can come to me and consult with me. All right, I can teach you a couple more other techniques like the total variation principle and other versions of the Tikhonov regularization. Okay. So that means pagkatapos natin ng singular value decomposition, probably 2 or 3 meetings starting on Tuesday next week. We can relax a bit after that. Then you focused on your remaining problem sets and project for the course. And as far as requirements are concerned, parang no, parang ang aga nagpapaalam na kagad ako for the semester sa 191. Para rin maplano nyo yung natitirang mga araw ng semestre kasi though we will be more relaxed in the lecture, meaning I won't be teaching you new tools or mga bagong concepts, mas magiging hands-on yung mga susunod na araws para sa inyo or mga susunod na linggo. Number one, I think we'll have medyo may pagbabago. Instead of one homework, we'll have 2 homeworks left. One will be due probably on kailan kaya? An easy one will be due probably, let's put it on Monday, Tuesday tayo, no? So Monday right before midnight. And then another one will be due the next Monday. All right. So yun yung ibibigay ko probably later today or tomorrow. And then we'll have one problem set which will be due on the last day of classes. Pero kaya ko naman siyang i-extend. Ano ba last day of classes natin? December 21, if I'm not mistaken. Or December 15. I think it's 21. Tama ba? Yeah, it's 21. So ipapa-deadline yung second problem set, pwede ko ipa-deadline on December 21. Though again, we'll be finished with the coverage of that problem set in 3 meetings. So you'll have a lot of time to work on it. We can also discuss this in class if you have some problems or work the codes together for that problem set. So, but I can extend it until December 21st, December 24th. Kung talagang kulang yung oras nyo and you're willing to sacrifice some of your Christmas break, sige, papayagan ko kayo mag-submit hanggang December 24 bago mag-Noche Buena, so before 11:59. Pero I encourage you to finish everything before you go to the Christmas break kasi sayang yung Christmas break, that's the time that you can relax with your families. But of course, we cannot, I know ang dami yung tinitake, so I am willing to give you as much time as possible. And then the final project which you can do probably siguro papayagan ko na kayo na mag-group sa final project. So start talking with each other. If you share some common interests, kasi di ba ang usapan natin, you can you can think of a practical application related to your field or to your specialization or to your interests. Or kung meron kayong nakitang isang partial differential equation na na medyo kamukha nung heat equation na ginawa natin, you can redo everything that we did for the heat equation or for the convolution problem, pattern your project with it, just a different governing equation, and then but same processes, you can do that. All right. So start talking in groups. Ilan bang gusto nyong groupings? Siguro we can talk about it next week pag mas marami yung present. Siguro 3 to 4 members in a group, that would be fine. I can also assist you in finding group mates, ano? Or you can work solo if that's more convenient and more more convenient and that's your preferred mode of working, ano? But the deadline for the final project would be on the finals week. All right. Siguro pwede sa last day ng finals kasi kokonti naman kayo sa klase. So, pwedeng ipandulo na natin yung Math 2191 para mauna niyo yung mga mas demanding na courses. So, that's it. And after that, we'll be done. So, 2 homeworks, 1 problem set, and the final project, you'll be done with Math 2191. Pero dun sa mga advices ko dyan, gagamitin pa natin yung mga natutunan nyo dito sa inyong SP or thesis come next year or come next semester, all right? So don't forget the things that you learned in class. Okay, so that would be our housekeeping matters. Sige, announce ko na rin yung homework. I think homework number 6 would be a reaction video, a reaction paper, or a reaction podcast to the 2 videos that I asked you to watch. Diba, instead of meeting last Tuesday, I apologize for not being able to meet you. Meron akong hindi matanggihan na isang meeting, and the meeting cannot go on without me. And that's the only time na may common kami. So, yeah, and I thought kayang-kaya naman nating isingit sa schedule yung 1 free day, all right? But it turns out it's not a free day for you because you have to watch those 2 videos. The videos about singular value decompositions, have anyone watched the video? Or hindi pa? Inunan niyo yung ibang course. Sige, hindi ako magseselos kung inunan niyo yung ibang courses, ano. So, kasi sabi ko naman dun sa video assignment niyo, panoorin niyo siya before we do the Tuesday meeting, all right? Because I will not introduce the singular value decomposition anymore because I cannot discuss it clearer than what who was that author? Was it Brunton? The guy on the video did. Ang ganda nung discussion niya about singular value decomposition. He started about talking what singular values are, what are the physical or practical interpretations of singular values. At siguro ma-realize na when we go to the truncated singular value regularization next week, you will realize, kaya pala pumipili lang tayo ng mga matataas na singular values. Kasi all of the other lower singular values may represent noise. So by just ignoring the smaller singular values, we are giving more priority to those singular values and their singular vectors that really matter. All right. So ang ganda ng discussion niya. So kung di nyo pa napapanood, I hope you watch it over the weekend or before we do the Tuesday class. And that's why your next homework will be a reaction video, a reaction paper, or a reaction podcast to the 2 videos, just to make sure that you watch them. Ano? So para sure ako sa Tuesday or para confident ako sa Tuesday na pwede na ako mag-start dun sa truncated singular value regularization. Hindi ko na babalikan yung konsepto ng singular values. Number 1, because this is a concept that you probably have encountered in Math 120 or Math 105. Kung di pa kayo nagte-take ng linear algebra courses na yon, you might encounter them. And if I'll be teaching 120 or 105, I will definitely tackle singular value decomposition because aside from eigenvalues and eigenvectors, they are some of the or they are one of the most important concepts in linear algebra. So I think a course in linear algebra or matrix theory will not be complete if you haven't tackled singular value decompositions. All right, kasi kasing halaga siya ng eigenvalues and eigenvectors. Some will go on saying that it's a more generalized measure of importance than eigenvalues and eigenvectors. So that's it. Don't worry. I'll send you a reminder later today about that particular homework number 6, reaction video, podcast, or paper, kung saan kayo mas komportabling medium. All right. So para dun sa dalawang videos yan. It doesn't need to be long. It could be about half a page na reaction paper. It could be a 1-minute video. It could be a 1-minute podcast. If you want to go beyond, that's fine. But yeah, wag niyo masyadong habaan. Wag niyo masyadong hindi kailangan masyadong formal. Kung written, siguro formal. Kung research paper, I expect it to be a little bit formal. It would be in pure English or in pure Tagalog. But if you'll be sending a video or a podcast, feel free to use the vernacular Taglish. So, okay lang yan. Ano? Pero pagka paper kasi mahirap. May ebidensya kasi pag paper. So, be as formal as possible dun sa paper. So that's going to be homework number 6. And then, eto na. So any questions about that first? Though I'll send an announcement later for the benefit of those who are not able to join us today. Any questions? Or napanood nyo na ba yung video o hindi pa talaga? Sige nga, show of hands. Parang si Prince napanood nyo na. No? So, okay. Okay, good. So, but if you haven't done so, yeah, you still have until Tuesday, siguro Tuesday, Monday evening, kasi Monday right before midnight deadline yung reaction paper, podcast, or video on those 2 videos, right? Para masigurado ko on Tuesday, napanood nyo na siya. Para dire-diretso yung discussion ko ng singular value regularization. Okay. So now, up to the main event for today, and this is I don't know if it's the good or the bad news. I promised to discuss the Morozov discrepancy principle, which is basically a more elegant way of solving for the regularization parameter alpha. Or maybe I can share my screen here and do some doodling. Diretso sana ako sa Matlab pero sige. So that you get the context. Let me open my Notability. Okay. Okay, so remember, in regularization, we are striking the balance between the residual and the solution norm. And basically, that's the idea behind Tikhonov regularization. So see, Tikhonov solution, we're looking not only for the least square solution, meaning the solution that will give us the minimum residual norm, all right? In some sense, usually Tikhonov kasi ito ay L2 sense, so you're taking the L2 norm of vectors, functions, or matrices. So yun yung distinguishing characteristic ni Tikhonov. So it's based on L2 norm, on the L2 norm. L2 norm on whichever space is applicable. So sa atin, ang wino-work lang naman natin ay finite dimensional. So ang L2 norm natin, minimeasure, ay ginagamit natin pang measure ng size ng vectors and matrices. Pero if you go to higher level inverse problems na continuous yung problem, so pwede rin naman yung L2 norm in the space of integrable functions, all right? But that's fine. We didn't go there, pero yun, yung sa Tikhonov solution, nakadepende siya sa L2 norm. So basically, you start with taking the least square solution kasi siya yung may pinakamaliit na L2 norm ng error. However, we mentioned that that is easily tainted by measurement error or data noise, all right? So kaya sabi natin, to mitigate the effect of the noise on our solution, instead of just looking for the least square solution na binibigay na sa atin ng Moore-Penrose pseudo-inverse, sabi ni Tikhonov, kailangan hanapin natin yung balanse between the residual norm and the solution norm. So that's why we pick our solution x sub alpha to be the minimizer. So pag sinabi nating argmin, ito yung argument na nakakapag-minimize. So when you're minimizing, if you're looking for the minimizer or the maximizer of a certain function, ang tawag mo dun sa minimizer na yun ay argmin or argmax. Depende kung ano yung optimization problem. If it's a minimization or it's a maximization algorithm. So yeah, argument that will minimize, or pag argmax naman, argument that will maximize the given function. So sabi natin, ang Tikhonov solution natin ay basically the minimizer of this functional or this L2 measure, which is basically the residual norm. So that's AX minus B. You take the L2 norm plus, or actually minsan nilalagay pa natin yung square dyan, that's fine. Dun sa mga nag-optimization, alam ko merong mga OR dito sa klase. Bakit merong square lagi itong sa L2 norm? Probably if you're just curious, bakit may square pa dyan? Kasi we know naman, if we minimize the square, then we are minimizing the argument, right? Or the absolute value of the thing inside the square, right? Pero bakit nga natin, bakit laging may square usually? Kapag ka mga, lalo na kapag ka quadratic problem, kaya nagiging quadratic problem sila kasi nilalagyan natin sila ng exponent na 2. Do you guys remember? One thing to note here is that this would be an m by 1 vector, right? Kasi ito ay m by n. Tapos ang unknowns natin ay n by 1. So ito ay magiging isang m by 1. Ito ay m by 1, ito ay m by 1. So the difference will be m by 1. We're taking the L2 norm of an m by 1 matrix. But remember, the L2 norm of an m by 1 matrix is the square root of the sum of the squares, right? So kukunin mo yung error sub I squared, kukunin mo yung summation, tapos naka-square root pa siya. Just to get rid of the technicality of the square root, kasi ang square root ay meron siyang hindi magagandang properties. Number one, it could be the square root function. Usually pag optimization, nagdi-differentiate ka, di ba? So it makes the differentiation messy because you need to apply the chain rule and all. Medyo may point din yung sabi ni Daryl na mas maliit yung residual ng sum ng squares, which will make the fit better, right? That's fine. Pero yung idea kasi ay kapag ka na-minimize mo yung yung square root, nami-minimize mo rin yung square. Yeah, that will be your argument, Daryl, is on the right track. Pero I think the main purpose ay para matanggal talaga yung square root, because who wants to work with square roots if you have a way out of it, right? So kasi ito ay naka-square root ng sum ng squares, right? Error square root ng sum ng error squared. So ibig sabihin pag naka-square yan, mawawala lang yung square root, summation lang siya. So magiging quadratic siya, tapos parang as if it's a polynomial. All right? Or linear lang yung magiging property ng mga nasa loob. So you got rid of the square root, kaya usually nilalagay natin yung square. But putting the square is not required. All right? It's just an equivalent optimization problem. Nakita niyo na to siguro when halimbawa sa isang math, saan niyo pa ba to ginawa? I think sa math 36 when say, tandaan niyo pa ba yung mga problem na find the point on the line that is closest to a point in the parabola, halimbawa. So magmi-minimize ka ng distance, pero ang ginagawa ng teacher nyo, dahil ayaw niya mag-differentiate ng may square root, ang ginagawa niya, minimize niya yung distance squared. Just to get rid of that extra square root, hindi mo na kailangan mag-chain rule doon sa iyong, or mababawasan ng isang instance yung chain rule doon sa iyong differentiation procedure para makuha yung minimizer. All right? And that's that practical reason kaya usually nilalagay din yung square. Pero you can work everything out even without the square for the norms. Okay? Now, plus, again, sabi ni Tikhonov, hindi sufficient na ito lamang yung i-minimize natin. Dapat i-minimize din natin yung solution norm. So, kaya kaakibat ng minimization, kaakibat ng functional or ng objective function dito sa minimization routine na yon, yung L2 norm squared ng actual solution. Okay? Because the smaller the solution is, the less prone it is to errors in the less prone it is to noise, right? Pag maliit kasi yung solution mo, magiging mas maliit yung epekto nun doon sa, or magiging epekto ng noise sa kanya. Because for instance, if this is 10 to the 10th, and then you have a 1% multiplicative noise. So kung meron kang 1% multiplicative noise, tapos yung solution norm mo ay 10 to the 10th, yung Normia. So basically, yung epekto ng 1% noise na multiplicative is around 10 to the 10 times 1%. So that's going to be 10 to the 8. So medyo malaki siya. That's just 2 orders below the norm of the solution. But if you start with a smaller solution, so to speak, with respect to the L2 norm, halimbawa, ang L2 norm ng solution mo ay 10 to the second power lamang, tapos 1% din yung noise mo. So yung epekto ng multiplicative noise na yon, o if the noise is multiplicative, ang magiging epekto niya lang is about order 1, which is better, right? So parang yun yung naging idea rito sa Tikhonov solution. Pero again, you need to strike the balance between the two. You don't want to give up much of the residual error, okay, or the residual norm. Gusto mo pa rin, up to some level, accurate pa rin yung solution mo, pero kailangan mo mag-sacrifice ng kaunti or an acceptable value of that accuracy to minimize the norm of the solution. And I think I already illustrated to you before kung ano yung mangyayari pag sobrang laki or sobrang liit ni alpha dito sa iyong regularization procedure. Okay? So basically, this is what Tikhonov is telling us. Right? So yung pipili mong Tikhonov solution, yung regularized solution, would be the minimizer of this guy. Pero merong isang theorem na sinabi na si X alpha would be equal to alpha times identity matrix of the right size plus A conjugate times A inverse times A conjugate times the right-hand side B. So we're starting here with the system AX equals B. Then sabi ng isang theorem in Tikhonov theory, ang minimizer na to ay equal lamang dito, which is very much familiar to the least square solution. Because if alpha is equal to 0, this guy reduces to A pseudo inverse B, right? Kasi mag-0 lang to. Ito ay yung pseudo inverse, all right? So ibig sabihin, X alpha, when alpha is equal to 0, is simply the least square solution, which makes sense. Because if alpha is equal to 0, then the second term in your objective function goes out. So you'll be left with a minimization of the residual. So minimize mo lang yung L2 norm ng error, right? So, pero we want to get the balance between the two. Sacrifice some of the accuracy that you don't need in favor of minimizing the solution norm, right? Tapos sabi, hindi mo na kailangang isolve ay itong isang malaking optimization problem na yan. Kasi sa optimization problem na yan, meron kang almost 2 degrees of freedom. The first would be the alpha, and the second one is the unknown x. So you have to simultaneously solve for those two parameters or for those two minimizers. So hinahanap mo rito ay isang minimizing pair, right? Pero sabi ng Tikhonov theory, you can reduce the optimization or your problem into a single variable optimization routine. You just need to find alpha, the optimal alpha, because once you have the optimal alpha, then you can just compute for x sub alpha to be this guy, right? So basically, it's the pseudo inverse of a perturb. Hindi ko pala pwedeng sabihin perturb pseudo inverse to, no? Kasi ang pseudo inverse ay ito. So ipa-perturb mo muna yung diagonals ng A conjugate transpose times A, bago mo kunin yung actual inverse niya, because this guy is almost always invertible, times A conjugate transpose times B. So now, ang problema na lang natin ngayon ay paghahanap ng alpha. All right, what's the best alpha? Well, you can choose alpha to be ad hoc if you have an idea how big this is and how big this is, and say you want you know your priorities, and you say, okay, gusto ko 1% lang yung contribution ng norm ng solution norm, because probably you know that you cannot sacrifice too much from the accuracy. So you can put an ad hoc value for alpha. You can just say out of your gut feel or based on empirical results before, you can just set alpha to be, say, 1%. Okay? So, pwede mo na makuha yung regularized solution where you are giving a 1% weight to the solution norm. And that's fine, all right? And you just see for yourself if that is already acceptable, right? Pero tayo mga mathematicians, laging gusto natin, what's the best alpha? What is the near optimal alpha? And the cheapest way to do it, and I don't mean cheapest in a derogatory way, ano? So, I mean, ito yung pinakamadaling gawin. Though hindi siya ganun ka-computationally cheap, pero the alternative is much more theory heavy, ano? That's why most applied scientists use the L curve technique. And this is still on finding alpha, right? And we did an experiment with this, and I shared with you a code, yung L curve sample, but meron akong update mamaya. So you can go to Canvas and download the new file I uploaded. Pero the idea with the L curve is, para makuha yung near optimal alpha, kailangan nating i-plot yung residual norm, which is basically AX minus B. Plug mo lang yung norm niya. Usually, we do it in a log-log scale. So, basically, pwedeng yung logarithm nito, usually base 10, yung ipa-plot mo. And then, take the logarithm also of the solution norm. Okay. The L2 norm of the solution. Tapos, kunin mo rin yung log base 10. The idea is, sana makakuha ka ng parang L curve, L-looking curve. All right. Now, in Matlab, you can there's an easy way to get the log-log plot. Ano? Kasi kapag ka ito lang at saka ito yung pinlot nyo, baka hindi maganda yung scaling. Baka masyadong steep, hindi nyo makita yung curve, right? So it's better to do it in the log-log scale. Though pag ni-logarithm nyo to, pag hinard code nyo to, na pinaplot nyo kay Matlab, yung log base 10 ng residual AX minus B, tapos ang Y component ay logarithm base 10 ng X. Hindi siya mag-a-adjust yung scaling. So, ilolog niya lahat. Right? So, that's why I suggest when you're drawing the L curve, use the log-log command. So, log-log ng X components, Y components, X components being the residual norm, Y component being the solution norm. Right? And this principle, or the L curve principle, tells us that most probably the best choice for alpha will be the one living in the corner, because that's the threshold, or that's the turning point. That's the point of inflection. Because after that, you will not be gaining too much stability when you are giving up much accuracy. Kasi kapag ka nandito ka, tapos nag-move ka lang ng konti pa kanan, ibig sabihin nag-give up ka ng konting accuracy, ang laki nung makukuha mong change in the solution norm. And remember, the lower the solution norm is, the less sensitive you are to noise. Okay? Tapos, the more to the right ka naman, lumalaki yung error. So pagka nag-sacrifice ka ng konting error, pumunta ka sa kanan ng L curve, pag nandito ka sa point na to begin with, you go somewhere to the right, you are missing just a little bit accuracy. So napaka-konting accuracy lang yung gini-give up mo, pero you're gaining too much improvement in the stability. You're becoming less sensitive to noise kasi ang steep ng decline dito with respect to the run. Right? So yung ano bang kabaligtaran ng rise? Yung descend ay yung rate of descent ay exponentially larger than the than the rate of run. Okay? But after the corner, makita mo rito, you're already sacrificing too much accuracy but you're not gaining stability. All right? Kasi kung nandito ka, nag-move ka rito, so ibig sabihin, nag-sacrifice ka ng ganito kalaking accuracy, but look at the change in the y component. Napaka-negligible nung change in the y component. That's why a lot of people will hypothesize that the best alpha will be the alpha that will give you the corner point. Okay, and that's the point of the code that I shared with you. Na-calibrate ko na siya. Hindi ko lang talaga ma-recreate yung solution na nandun sa module for whatever reason. No? Pero tama naman yung code, dinibug ko siya. Yeah, siguro hindi lang maganda yung pagkaka-click ko. I don't know if you were able to get 7.81. Tama ba? Yun yung nasa handout, no? 7.81 times 10 to the negative 4. Pero wala talaga makitang mali dun sa code eh. Chinek ko rin yung version, yun yung eksaktong code na ginamit ko dun sa module. I was thinking maybe I was not clicking too much accurate. I'm not clicking precisely kasi nadala ng baha yung mouse ko. Hanggang ngayon, di pa ako nakakabili ng mouse. So, touchpad lang yung gamit ko. So, I don't know. But did you guys get a better, did you get a closer answer to the one in the module for that particular example? Or hindi nyo pa tinatry i-recreate? Pero wala talaga makitang mali eh. Parang 2 araw ko nang tinitigan yung code. Wala talaga makitang mali. So, but the results we got gave us improvements, right? Although hindi ko lang talaga ma-recreate yung nandun sa handout, ano? Pero I think that's good. So you can use it in the next homework, in homework number 7, which should be our last homework for the semester, right? So yun yung L curve. Tapos sabi ko nga sa inyo, medyo maggastos ito kasi kailangan mong isolve yung solution norm at saka yung solution norm at saka yung residual norm for a lot of values of alpha. Because really, we are fishing here. We are doing trial and error. So meron akong band of alpha. Meron akong alpha probably starting from 10 to the minus 16 all the way up to 1. Right? Kasi ang alam ko lang si alpha isang maliit na positive number. So what we did in the L curve ay kumuha ako ng napakaraming alphas. Tapos nag-trial and error ako. Sa bawat isang alpha, kinompute ko to. Alright? Tapos, sa bawat isang value na to, kinompute ko yung residual norm, kinompute ko yung solution norm, pinlot ko siya in a log-log scale. Tapos, kuha ko ng L curve or pwedeng inverted L curve or something like that. But essentially, the near optimal or the L curve will suggest the best alpha would be the one in the corner. Or kung walang corner, pwede mong ad hoc piliin. How much accuracy are you willing to accept? All right? So kung halimbawa, ito yung threshold mo, 1% yung hindi pala 2%, no? Kasi absolute error to. So kung gusto mo yung absolute error ay 10 to the minus 2, absolute error, so piliin mo lang yung point na nasa tapat nito. Right? Because here you're seeking what would be how much you can give. Right? Pwede mo na sulitin na halimbawa hanggang 0.01 lang yung gusto ko na AX na residual norm, then piliin mo na yung alpha na sakto doon yung mangyayari. That is if you cannot accept any error larger than 10 to the minus 2. Pero if you can afford a little bit and you see that there is much improvement in the solution norm, then choose that particular alpha, even if it's not in the corner. Pero yun nga, in principle, the corner will give you the near optimal alpha. Pero hindi siya totoo. Yun yung bad news ko sa inyo maya-maya. So yun yung ginagawa sa L curve, ano? So your next homework will be Inisip ko kung magpapa-L curve pa ako. Let's see, L curve, tapos actually pina-finalize ko pa sa isip. Meron kasi akong 2 option na homework eh. Pwedeng ad hoc or pwedeng L curve. Ganito na lang. Papa-ad hoc na lang ako. Tapos yung paggamit ng L curve and or Morozov principle ay sa ano na, sa problem set na. All right? But probably I'll devote one class meeting para i-discuss yung problem set. All right? Kasi dun sa mga comments na nakuha ko, not just here, pero sa Math 174 and Math 151, naubos daw yung oras nila pagbabasa ng instruction ko. So what I'll do to mitigate the to help you in reading the instructions, kasi medyo magulo nga ako magsulat ng instructions, masyadong mahaba. Pwede ko siyang i-discuss sa inyo in one of the sessions, just to make it clearer. And yeah, to avoid any misunderstanding in the instructions, right? So yun, doon na lang ako magpapa-L curve, ad hoc na lang yung susunod na homework. Okay, now, this is costly and parang hindi siya, quote unquote, parang hindi siya worthy of a mathematician because it's trial and error. And usually we mathematicians always frown upon trial and error. Bakit ka magta-trial and error? Naghahanap ka nga ng best alpha. Ang ginawa mo naman, sinolve mo siya sa lahat ng potential alphas, tas pinili mo yung best. So parang ang dami mong calculations na ginawa just to find one of them, just to pick one of them, right? Parang ito yung brute force approach. At alam niyo na, mathematicians, ayaw natin ng brute force approach, So one way to find alpha without going through the L curve routine is what we call the Morozov discrepancy principle. The Morozov discrepancy principle. And this will require us to solve a nonlinear equation, right? So essentially, what the Morozov discrepancy does is in the search for alpha or for the minimizer x sub alpha, ang ginagawa natin ay sinusolve natin itong nonlinear equation na to. We're solving for the roots of for the solution of this nonlinear equation, ax minus b squared. Square ko yung norm para mawala yung square root, para mas madaling isolve yung functional, plus alpha, and then this would be x, L2 norm ng solution equals some delta squared for some positive constant delta that is much less than 1. All right. So sinasabi ni Morozov discrepancy principle, huwag kang mag-L curve. So isolve mo na lang itong nonlinear equation na yan. Right? So maging nonlinear equation siya kasi ito ay sum ng squares. Tapos ito ay sum din ng mga squares times alpha. So this is a nonlinear. Actually, this will entail a lot of quadratic terms, right? Kasi ang variables natin dito ay x sub i's at saka alpha. So ang mga unknowns natin dito ay x1, x2, x3 hanggang ano nga size ni x? M by n. So it's n by 1 hanggang x sub n comma alpha. So we have n plus 1 unknowns for this nonlinear equation. Dun sa mga nag-math 175 na, kung matatandaan nyo, meron tayong section doon, how to solve nonlinear equations. Kasi nga, pagka nonlinear na yung equation, ang hirap niya ng isolve, right? So dun sa mga ngayon pala nag-174 at mag-175 next semester, you will learn how to solve or how to approximate solutions to nonlinear equations, right? Pero dun sa mga nag-175 na, tandaan niyo pa ba yung mga methods paano natin sinolve yung mga nonlinear equations? Which gives me an idea now. Siguro sa 175 next semester, ang isang problem sa problem set sa chapter na yon ay isolve itong optimization problem na to. Itong Morozov equation na to. Kasi dati ang pinasolve ko sa mga 175 students ay yung kailangan kong eigenmodes para sa propagation ng sound sa isang ocean. So though it's a very applied problem, pero ano lang siya, isa lang siyang nonlinear equation na nasolve naman nila. Okay, nahanap nila yung eigenmodes, pero yung modeling syempre hindi ko diniscuss. Binigay ko lang sa kanila yung equation na isosolve nila, then they ran some methods. So dun sa mga nag-175 na, sige, mag-roll call ako sa mga nag-175 na. Tandaan niyo pa ba yung mga methods paano tayo nag-solve ng nonlinear equations? Or kinalimutan niyo na sila? Meron tayong mga bracketing methods, if that ring bells. Ano yung mga bracketing methods natin? Meron kang tawag doon? Bisection method, regular falsi method, the secant method, ano pa ba? Fixed point iterations, tapos meron pa tayong Newton-Raphson. Alright? Actually, ang ginagamit ko usually, and it is implemented in the Morozov code that I gave you, ay yung Newton's method. So ito, isolve natin to numerically using numerical solution using Newton's method. Kasi mahirap tong isolve by hand. And I don't think Matlab can help you find a symbolic solution. Kaya numerical yung magiging solution, maraming methods na available, pero isa sa mga pinakasimple ay yung Newton-Raphson method, which converges quadratically. So ang order of convergence niya ay big O of h squared, and it will almost converge as long as the derivative of the objective function is not equal to 0. Right? Pero for this course, don't worry about that. Yung code na binigay ko sa inyo, you can just run it and it will give you the optimal alpha. And actually, the solution, x. So kasi simultaneously niya isosolve yung mga components ng solution x at saka ni alpha so that this sum will exactly be equal to delta squared. Pero ang problema rito ay ano si delta squared? Sir, nag-introduce ka na naman ng isang parameter. Problema na nga natin si alpha. Well, delta squared or delta actually is your error threshold or is your threshold for the value of this sum, right? So pwede mo siyang tingnan ano yung kaya mong i-tolerate na value ng residual squared plus alpha times the solution norm. So you'll be the one picking out delta, right? So pwede mo sabihin, siguro delta, I can afford you to save to become 10 to the minus 3, right? Para yung algorithm ko, ang isosolve niya ay kailan yung sum na to, instead of minimizing this sum. Of course, I want this sum to be very, very close to 0, right? Because Tikhonov's principle tells us ang gusto mong x sub alpha, the best x sub alpha that you will get is the minimizer of this guy. Ito ay non-negative to, right? Because this is something squared, this is something squared, so this is something squared, this is positive, so positive, or actually not positive, non-negative plus non-negative, you'll get a non-negative number, and the minimizer of that would be a non-negative number, the smallest possible value of which will be 0. Kaya lang ang hirap mag-solve ng optimization, right? Lalo na non-linear optimization. Problem na to na yung hindi lang siya quadratic. Although kaya mo siyang i-solve using quadratic programming, pero baka hindi mag-converge yung method. So minsan SQL yung ginagamit, sequential programming, quadratic programming, SQP, pero usually hindi rin siya nagko-converge. All right? So kaya mahirap i-solve ito as a minimization problem. But you can do it ad hoc. Just tell us, or just tell your computer what is the tolerable value of this sum for you. Of course, you want it to be close to 0. But if you have a little bit of a wiggle room, you don't need this to be very, very close to 0. Probably you can afford it to become, say, 10 to the minus 3, 10 to the minus 4, and so on. So kaya ikaw yung magbibigay. Ano yung acceptable delta? Tapos ang isosolve ng Morozov routine mo ay ano yung mga components ni x at components ni alpha that will make this equation true. And we do it, as I've mentioned, using an iterative technique called the Newton's method. So meron pa rin, manghuhula pa rin siya up to some point, pero yung panghuhula niya ay towards the minimizer. Okay? So instead na katulad nung sa L-curve, magko-compute ka ng 1 million possible alpha values, right? Dito sa Morozov discrepancy principle, yung Newton-Raphson method, baka kailanganin niya lang ng 10 iterations. So instead of computing 10 million, computing a million possible alphas, all right, or working with a million possible alphas, kailangan mo lang pala ng 10 iterations para makuha yung solution from the Newton-Raphson algorithm. That's why this is much mathematically preferred. Kasi hindi to hindi siya trial and error. You'll not be fishing for which alpha is best from a select few. All right? Pero Ang problema rito, which also is my problem, which is the bad news now, I shared with you the Morozov discrepancy principle code that I am using. Kaya lang hindi ko siya ma-apply dun sa hindi ko siya ma-apply dun sa convolution problem kasi hindi ko alam yung delta na dapat kong piliin. Kasi yung ax minus b, whenever I have noise, napakaliit nito dun sa convolution problem. Alright? Kasi napakaganda nung fit with the noisy data. Alright? Ito ay ax minus noisy data. Dapat pala tinest ko ay ax minus the true data. Kaya lang hindi siya mag-work from a physical point of view because we don't know the true data. Alright? Kasi, I mean, the problem that I encountered kanina nung nagra-run ako ng simulations, di ba sinusolve ko itong ax equals b plus epsilon dun sa convolution problem natin. Convolution problem. Ax equals b plus epsilon yung sinusolve ko. Kasi nga, sabi ko, sa totoong buhay, wala akong access kay b. May access lang ako sa b plus measurement error. So I'll take that as my data, tapos isusolve ko to. Right? Kaya lang, dun sa solution na nakukuha ko, napakaliit nito. Napakaliit ng error dito kasi ang ganda masyado nung fit nung x na nakukuha natin mula dun sa noisy data. So pag kinuha ko yung ax minus quantity b plus epsilon, kinuha ko yung normia, usually ito ay nagiging 10 to the minus 16. So kung ito ay 10 to the minus 16 na, tapos magdadagdag pa ako ng solution norm ni x, alright? So si alpha, na-force siya to be 10 to the minus 20 or 10 to the minus 30 or even less. Or, so ibig sabihin, within machine precision na yung value ni alpha, and then magkikick in naman yung round-off errors dun sa machine. Kasi nga, kapag ka meron ka number of magnitude 10 to the minus 16 or less, kapag ka ginagamit mo siya sa computations, virtually zero yung nagagamit. So it doesn't make sense to use that alpha because I'm just going back to the least square solution. Kasi si alpha napakaliit na from the point of view of the machine. Or even worse, meron pa akong isang problema kasi nga hindi ko alam yung value ni delta na ibibigay. Or hindi ako makahanap ng magandang value ni delta. Kasi nga kung ito ay 10 to the minus 16 na to begin with, pag ini-square ko pa yan, magiging 10 to the negative 32 plus alpha times the norm of the solution happens to be also very small. Tapos i-equate ko to sa usual choice ko kasi 10 to the negative 3. Right? And then alpha becomes infeasible kasi nga si alpha dapat ito ay less than 1. So kung ito ay 10 to the negative 32, then this is something of around the same order times order 1, never na siya magiging equal sa 10 to the negative 6 or 10 to the negative 3 squared. So ibig sabihin, lalabas na ako dun sa feasible region. Kasi ang feasible region ko lang dito ay yung alpha ko ay less than 1, but greater than 0. So na-force si alpha to be outside of the feasible region, nagrereklamo na sa akin si Newton-Raphson. So sabi niya, wala naman solution yung pinapasolve mo sa akin eh. Kasi kung anumang x yung piliin ko, I couple it with even a very small or very large alpha, I cannot get the delta squared. Yun yung naging problema ko rito. So in your problem set, I'll devise another problem. Medyo ad hoc ko na siya gagawin. Hindi na yung convolution problem, hindi na yung heat propagation problem kasi nga super liit nung alpha super liit nito para sa kanila. So kailangan nating i-modify ng kaunti yung method. Kailangan ko ritong mag-divide by some scaling constants para magkaroon lang ako ng feasible na delta. Alright? Pero mahaba-habang analysis yung kailangan ko para ma-compute yung denominator o yung scaling constant na gagamitin ko rito. Kasi instead of alpha, maglalagay pa ako rito ng isa na beta, alright? Para lang ma-balance out yung weights between the residual and this guy so that the Morozov discrepancy principle applies. Tapos nung dinouble check ko yung Morozov na ginagamit ko dun sa pag-model ng sound, lagi ako merong over area ng region kung saan ko gustong hindi pala area ng region. Norm ng function over the region region omega kung saan ko gustong or i-control yung sound. So dito sa problem natin, dahil wala naman tayong actual geometry kasi it's just a one-dimensional problem, ano? So pag dinivide ko ang ating length ng ating space na pinaglalaruan is just 1 or 2, right? So we are just working with the interval 0 to 1 for the convolution problem, or the spatial distribution 0 to pi in the backward heat propagation. So hindi naging meaningful yung pag-scale ko by just the area of the geometry. Or if I integrate the function I want over the geometry that we're considering, kasi maliit pa rin masyado. Actually, maliit pa rin masyado yung mga norms na nakukuha ko. So kailangan ko mag-compute ng kakaibang scaling constant beta na ilalagay ko dito sa harap ng residual. Kaya lang modified na yun, Tikhonov procedure na masyado ng advanced para sa course natin. So yun na lang yung remedyo. So hindi ko ma-demonstrate yung Morozov discrepancy principle dun sa examples natin sa klase. And I guess this is the cost of doing various kasi parang ginawa ko tong research class, so merong specific problem tapos saka lang ako on the fly nag-iisip ng solution. Tapos sinilip ko si Siltanen, kasi ganito yung examples niya. Kinuha ko kasi yung examples niya tapos sinatry kong i-apply yung mga sarili kong methods para malay nyo makagawa tayo ng book similar to what Siltanen wrote, pero kakaiba yung mga methods na ginamit natin. Pero yun pala, nagkaroon din ng ganung problema si Siltanen. Kasi yung L-curve ni Siltanen, saka may discussion din siya ng Morozov, pero ad hoc, hindi rin nagko-converge. So talagang there's something with the heat equation and the convolution problem he presented na hindi right away nag-apply yung classical L-curve at saka yung classical Morozov. Of course, we're getting meaningful results from the L-curve, pero at least for the convolution process, pero yung Morozov hindi ko siya mapagana. Tapos dun sa backward heat propagation, hindi rin nag-converge yung L-curve method ni Siltanen. Okay? So yun. So ang next problem set, mag-iimbento ako ng ibang problem, pero ipapagamit ko doon sa inyo yung Morozov code na in-upload ko kanina. Alright? Which brings me to some Matlab tutorials for the next 20 minutes or so. But I guess that's the main gist of the Morozov discrepancy principle. Do you guys have any questions? Kung you want to learn more of the theory, kailangan kasi ng maraming background sa linear algebra at saka sa functional analysis. Pero I think you can do it. Ano lang naman, mga norms lang naman yung pinag-workan. So if you work with norms before, you can appreciate the discussion of Siltanen of the Morozov discrepancy principle. Pero ito yung main gist niya. So magsosolve ka lamang ng isang nonlinear equation. So medyo graduate level na kasi yung analysis ng Morozov method. But in principle, that is just that. You're solving for x and alpha that will satisfy this for some delta of your choosing. Okay? So lilipat ako sa Matlab just to demonstrate the two codes that I shared. Una ay yung lcurve.m at pangalawa ay yung Morozov 191.m. Nakaka-upload ko lang kanina, so you can download it later. Pero any questions before we move on? Okay, give me a 2-minute break muna tayo for 2 minutes. I'll just need to check an important email. Pero when we come back after the space, magma-Matlab naman tayo, Kasi medyo kakaiba yung dalawang code na shinare ko ngayon. Kasi sila ay external functions or mga external subprograms sila, which I think would be better kasi mas madali silang i-incorporate sa mga codes na gagamitin nyo. instead na .m siya na individual script, na ika-copy-paste mo siya whatever. So, dahil isa na siyang subroutine o isang subprogram, pwede kayong sumulat ng isang MATLAB script, tapos i-call niya na lang yung subprogram na yon. In that way, you don't have to worry about variables overlapping with each other and so on. Lalo na kung ilalagay niyo siya sa isang for loop. Okay? So 2-minute break and then I'll be back with MATLAB. All right, guys? All right, so I'm back. Hopefully, nandiyan na rin kayo. So here's the first code that I want to share with you. But this is essentially the same. The content of this code is very much similar to the one that I shared to you last week. Tama no, na-share ko na sa inyo yung L curve sample na code. Ngayon, ito naman ay yung code na ang title niya lcurve.m. Maybe I can annotate my screen. Hold on. On ko lang yung annotation. Kaya lang medyo matagal tong mag-load. Yun nga lang mas maganda kay Zoom. Mas mas seamless yung niya. Mas seamless yung annotations kay Zoom. Pero anyway, so essentially this is the same, the content is the same, except that now this is not a standalone script. Hindi na siya isang standalone program, pero isa na siyang sub-program. So, pangit ko talaga magsulat sa screen ng laptop. Pero anyway, so isa na siyang sub-program, and the benefit of this, you can call this sub-program in another script. Tapos, independent to. Kasi external function nga siya or external program nga siya. Ang variables na ginagamit dito sa function na to, dito sa subprogram na to, ay hindi nakaka-apekto dun sa variables na nandun sa main program. Alright? So you can think of it as a function talaga. So it's a function called lcurve. Oops. Kailangan ko pala itong off. How do I off? How do I turn this off? Ayan, nag-open pa kasi ako. Hindi ko maalala kung paano nag-off. Okay, there you go. Yeah. So, yeah. So, external siya kasi pwede mo siyang i-treat as a simple, like a mathematical function, right? So, this function is called lcurve, right? So, yung lcurve function, it takes two inputs. Meron siyang dalawang variables as inputs. Input niya ay si matrix A at saka yung right-hand side B ng system mo. Right? Yun yung ibig sabihin nitong line number 1. The function command here simply tells Matlab, hindi to usual na script. Ito ay isang external function. Alright? Isa siyang function, ang pangalan ng function ay lcurve, which also happens to be the title or the file name, lcurve.m. Alright? So siya yung function lcurve, ang pangalan niya, tapos ang inputs niya ay matrix A and B. Tapos ang output niya ay ito. Merong dalawang output itong functions na to. Itong function na to. Una yung optimal alpha at pangalawa ay yung x sub alpha. Alright? X sub alpha is the solution using the optimal alpha. So dalawa yung ibabalik sa atin. So when you call lcurve in your big program or in your main code, alright? Ang ibibigay niya sa yung output ay dalawa lamang. Pag binigyan mo siya ng matrix A at right-hand side vector B, ang ibibigay niya sa iyo ay dalawang bagay. Una yung optimal alpha, tas pangalawa yung x sub alpha, yung solution using the optimal alpha. And essentially, buburahin ko lang or binura ko lang etong pagko-compute ng A, B, and EB. Because A, B, and EB will be passed on by the user to this command. Right? So hindi mo na to actually kailangan buksan. Etong lcurve.m, wala ka na ditong babaguhin. I-call mo na lang ito sa isang main script. Right? So basically, I can delete these lines. Okay, pwede nyo na rin siyang i-delete kasi wala naman siyang gagawin talaga. Kasi yun yung kinopy-paste ko mula dun sa lcurve sample na isang standalone script. This is an external function, so hindi na ako dito nag-i-input kung kanino niya i-implement yung lcurve, right? Kailangan ko pa rin tong alpha. Now, if you want to consider smaller alphas, then you can go to the lcurve function and then replace this. Palitan mo lang yung step size. Kung gusto mong mas kokonting alpha yung i-consider, that's fine. Pero yung pag-i-input ng A at saka ni B, hindi mo na dito gagawin. Right? And then it will do the usual lcurve routine na ginawa natin last time. Nandyan pa rin yung G input, nandyan pa rin yung pag-drawing ng lcurve at pag-display ng solution. Okay? So andyan pa rin siya. Now, the thing is, right? Ang kagandahan sa kanya ay pwede siyang i-incorporate sa isang main scripts or sa isang bigger Matlab code. Okay? So, halimbawa, punta ako dun sa sa psf.m. Tapos, halimbawa, generate ko yung data. Remember when I run psf.m, magkakaroon ako ng mga data, right? Kaya lang, matagal mag-run yung psf.m. So, ang ginawa ko ay sinave ko na lang yung mga data into convdata.mat. So, ilo-load ko na lang to. So, ibig sabihin is it's as if I ran everything dito sa psf.m. So, nakuha ko to. Tapos naisipan ko, kailangan ko palang mag-L-curve. Right? So, instead of running or going to an L-curve routine, pwede mo nang isipin ngayon si L-curve to be simply a built-in function na. Kasi sinulat mo na siya sa function as long as lcurve.m is in the same folder as you are. So makikita mo sa current folder sa left, all right? So pwede mo equal si lcurve even without opening lcurve.m. So ang gagawin mo lang, lcurve, all right? So yung pangalan nung function, ng external function o nung subprogram. Tapos remember, ang input ni lcurve ay A at saka B. So balik ako dito sa actually it doesn't matter kasi dito lang naman ako naglalaro sa command window. So L-curve of A and B. A is our matrix A in the system. Tapos tingnan niyo yung workspace, meron na dyan naka-load na matrix A. Ito yung matrix A dun sa convolution problem natin. So pwede ko siyang ilagay dito, A. Tapos comma, second input would be B. So pwede ko ngayong ilagay yung exact data. Halimbawa, so ang exact data natin ay, what's our exact data? Our exact data, yung right-hand side natin sa PSF ay data Y. Pero kailangan kong i-transpose. So all I need to do is to type L-curve and then give it the intended inputs. The intended inputs are A and data Y prime. Tapos I'll hit enter sa command window. Hindi ko binuksan yung lcurve.m kasi external command nga siya. Okay, medyo matagal kasi hindi ako nag-OpenGL. Bumalik yung problema ko sa graphics. Yeah, hold on guys. Nagra-run pa siya. Wala mo bakit. Nag-hang pa rin yung graphics ko. Akala ko na-solve ko na to last time. Do you guys also encounter the same problems? Bakit ang tagal niya? Ano nangyari? Hold on guys. Let me restart my Matlab. Bakit di ako nagkakaproblema? Isip ko dati baka yung graphics card ko. Pero nakakapaglaro na uli ako nung talagang games eh. Nakakapaglaro na uli ako nung Nakapaglaro na uli ako ng mga heavy graphics na games sa laptop ko eh. Hindi na siya naglalag. Yung Matlab na lang talaga. Kita yung priorities eh, no? Hold on, let me do it again. Pero nakailang run ako kanina, naka for loop pa, hindi siya nagkaganto. Bakit kaya siya nag-crash ngayon? Kung kailan klase, no? Pinapahiya talaga ako nito. Problema ko, dinilit ko yung Matlab 2020. So, hindi ako makapag-revert dun sa lumang version. So, let me do OpenGL first. Okay. Tapos, Load ko yung convolution data. So it's as if we ran psf.m. And then there you go, nasa workspace na dito sa right module, yung A, at saka yung lahat ng data na kailangan natin. Data X would be the X values that we have. Data Y, ito yung measurement data dun sa convolution process o dun sa convoluted function, A star F, right? So ngayon, kailangan natin i-construct ano yung true data. Yun yung problema natin dito. So I hope this will work now. Okay, para mas okay pala, hindi ko lang iraran yung L curve, pero isi-save ko na yung outputs na makukuha ko sa L curve. Kasi remember, if you go to the L curve routine, okay, meron siyang dalawang inputs, A and B. So sundin nyo lang yung what do you call this? Sundin nyo lang yung format dun sa function, dun sa external function. May end naman ako na nakalagay. So dito, dalawa yung inputs niya, A and B. So, tapos meron siyang dalawang outputs, alpha optimal and X alpha. Yung alpha optimal, it refers to the variable alpha optimal that will come out of the L curve. So makita nyo, dun sa loob ng external function, may kinocompute siya na alpha opt. So whatever alpha opt is, ito lang yung ibibigay niya na output. But you can save that output in any variable that you like. So for instance dito, alpha opt, siya yung first output. Pwede kong tawagin yung magiging output ng L curve to by another name. Diba, tawagin ko siya best alpha. Okay? So si best alpha, siya yung magiging first result ng L curve routine. Ang first result ng L curve routine ay alpha opt. So kung ano man yung alpha opt na masosolve dun sa loob ng L curve.m ay papangalanan niyang best alpha pag lumabas na siya ng function. Okay? Tapos comma, yung X alpha pwede kong tawaging F ng L curve. F L curve. Halimbawa. Tapos equals, etong dalawang variables na to, yung vector consisting of best alpha and FL curve ay makukuha by running L curve with the following inputs, A and data Y prime. Data Y prime. Kailangan ko yung data Y prime kasi kung makikita nyo sa workspace, si data Y ay 1 by 64. Kailangan dapat, di ba, 64 by 1, dapat column vector, kaya kailangan ko siyang i-transpose dito. Then hopefully, mag-run na siya. Tayo niya mag-continue. Or matagal lang. Kailangan maging patient daw. Pero nung ginawa ko to kanina, hindi to ganun. Baka dun pala sa heat equation yung matagal. Yung mabilis. Kasi 10 by 10 lang yung matrix doon. Dito 64 by 64. If you have some doubts kung nag-work nga ba ng tama, pwede niyong i-pause para malaman kung saan siya tumitigil. So, ibig sabihin dito, nag-pause na siya. Okay, I see. Nasa iteration 394,670 pa lang siya. Remember, we're expecting 1 million iterations. So, about 40% done. So, continue. Bayaan natin siya mag-continue. So, nasa 40% pa lang siya. At least alam natin nag-run siya. No? How about sa inyo? Habang nag-run siya, ganun ba talaga katagal? Or bumabagal na lang talaga ang laptop ko? Okay. Medyo impatient ako, so ipopause ko ulit. Tingnan ko lang kung nasang iteration. Okay, there you go. Mali yata yung pagkakapause ko. Dapat hindi na ako okay. Katatapos niya lang. So I let it continue. Okay. So ito, binigay niyo na sa akin yung L curve. Tapos mag-G input na ako ngayon. So I'll choose the point wherein I have acceptable residual norm and the best solution norm. All right? So limbawa, okay, payag ako na hanggang dito yung aking accuracy because kung makikita nyo dun sa x-axis, nasa pagitan na ako ng 10 to the negative 2 at saka 10 to the 0. So that means the residual norm is around 0.01 and 1. Though this is absolute residual, all right? Kung gusto nyo, pwede nyo i-convert yung residual norm into relative error. Pwede nyo i-divide by the norm of B para percent yung makikita nyo, right? But this is not in percent, this is in actual magnitudes. So I can I can probably go here and then click it. Tapos, okay, bibigay niya sa akin yung point na yun. And then, if I look at my workspace, meron akong best alpha, which is essentially the name that I want to give to my to the solution from the L curve. And ano pa yung isa nating hiningin variable? Hiningin nating variable pa ay si FL curve. All right. So si FL curve ay equal dito, which is actually the X alpha coming from the L curve routine. Tapos makikita niyo na siya sa workspace. And then the nice thing about working with subprograms or external functions, meron mga variable dito sa loob ng L curve na posibleng hindi nyo naman kailangan. Halimbawa, meron siyang variable na x-test. Kung makikita nyo sa workspace, wala na ditong x-test. Kasi ang kagandahan ng external functions, hindi niya sinesave doon sa actual memory or doon sa actual workspace yung mga variables na nandun, local, doon sa external function. So parang sinesave niya lang to sa isang temporary memory kung saan habang nag-run si L-curve, nandun yung variable na x-test, nandun yung sol norm, nandun yung residual norm, and so on. So kumbaga nasa RAM lang siya nagstay. Hindi siya nagstay sa actual hard drive. Right? So ibig sabihin, hindi siya mag-overlap dun sa mga variables na ginagamit nyo dun sa main code. So you don't have to be extra careful about the variables that you need. At ang isa pang kagandahan nito, you can call it whenever you are inside a different program. Okay? So, yun yung kagandahan ng paggamit ng external functions. Now, kung gusto nyo itong gamitin inside some bigger code, so pwede naman, right? Gusto nyo i-plot yung solution. Kaya lang dito sa plot, sa psf.m, ang pinaplot natin ay fsol noise, right? Halimbawa, ang gawin kong fsol and noise ay iset ko to be equal to the FL curve. FL curve. I-overwrite ko yung existing na fsol noise to be FL curve. There you go. Tapos pwede ko nang i-run ito. Tapos mag-F9 na lang ako dito. And then I should be getting the plot using the results that I got from the external function. And then here we go. This is our reconstruction, which is far better than the reconstruction from the noisy solution. But actually, hindi pala to noisy data, no? Kasi ginamit ko rito ay perfect data. If you recall, yung ginamit ko sa L curve, hindi ko pala nilagyan ng noise. Kasi ang in-input ko sa L curve routine natin ay data y prime. So ibig sabihin, exact data yung ginamit ko. So if you want to input instead a noisy data, so palitan nyo lang to ng data y prime, data plus the noise, tapos quantity transpose. Tapos mag-run lang uli yung L curve routine. Okay. So I want you to explore the use of this external command. Now, as I mentioned kanina, pwede nyo itong i-incorporate sa loob ng isang bigger code. Halimbawa dun sa heat diffusion process. Right? Dun sa heat diffusion process, pwede kong i-copy paste yung buong laman ng L-curve routine papasok dun sa heat diffusion. Kaya lang it will be inconvenient, especially if you will be doing that for a lot of other programs. Ang mga si L-curve, gamit na gamit mo sa lahat ng mga scripts na sinusulat mo. So it would be more convenient to really just call L-curve repetitively whenever you need them instead of copy-pasting all of its contents into a main script. So halimbawa dito, heat diffusion. Nasulat na natin to before, tama? So medyo minodify ko lang to ng konti. Naglagay ako ng line 7 wherein tatanungin niya yung user kung gusto mo mag-regularize o hindi. Kung ayaw mo mag-regularize, set regularize to 0. Pero kung gusto mo mag-regularize, gawin mo tong equal kay 1. So I think na in-upload ko na rin tong heatdiffusion.m na bago. So you can check it out dun sa ating Canvas page. So dapat may line 7 siya na regularize or not. So put 1 if you want to regularize and put any other number if you don't want to regularize. All right? Tapos ang isa pa niyang pagbabago ay dito sa line dun sa for loop, dun sa pagsasolve na ng backward problem. Oops, sorry. Actually, simula dito sa n. Naglagay ako ng ending value for n. Kasi nakita natin before, hindi stable yung backward heat propagator, all right, sa lahat ng time values. Remember, actually, parang sa perfect data, 7 time steps lang yung nakaya nating balikan before the relative error goes beyond 5%. So, may control na tayo ngayon kung hanggang saan lang natin gustong i-run yung algorithm. If you want the algorithm to run until t equals 0, so put 1 here. Ito yung ending value ni capital N. Pero kung gusto mo 5 steps lang yung gagawin, pwede mong palitan si nn by n minus 5. Alright? So kung gusto mo 5 steps lang yung gagawin niya, kasi alam mo na after 5 steps, siya ay magiging, magiging unstable na yung solution or useless na yung solution kasi lampas na ng 5% yung error. Okay? Now, dun sa for loop, meron na itong dalawang options. Kapag ka yung regularize ay equal kay 0, baliktad pala yung sabi ko kanina. If you want to regularize, do not put 0. Alright, yung pala yung nasa if then ko rito. Kung ayaw mo mag-regularize, set regularize equal to 0. Because if that is the case, mababasa ni line 146, doon ako papasok sa line 147. Ito yung usual inversion, the naive reconstruction for the backward heat equation. Okay. Pero kapag gusto mo mag-regularize, put any value to regularize aside from 0. Remember kanina ang regularized value natin ay 1. So pupunta siya sa else, so pupunta siya rito. Okay. So comment ko lang yan. Ito yung gusto ko. Yung lines 150 to 151. Okay. So ang gagawin dito ay, kung makikita nyo, dito sa line na to, tatawagin niya ng paulit-ulit yung L-curve. Kasi nasa loob to ng for loop, diba? For loop from for loop on J from from N to N end. Pero dahil gusto kong mag-L-curve sa bawat isang backward reconstruction, kaya sa copyin ko yung buong laman ni L-curve.m, pwede ko na lang siyang gawing isang external function like what I did. And then makita nyo sa loob ng for loop, tinawag ko lang si L-curve para lang siya, parang built-in function na siya ngayon. Si L-curve, ipapasa ko lang yung matrix A na compute sa line sa taas, dun sa propagator, sa line 38. Until 49, kinompute dun si A. So, tapos, ipapasa ko lang siya kay L-curve. Kasama niyang ipapasa ko kay L-curve yung matrix B na right-hand side, which I defined here. Ito yung right-hand side. Ito yung previews. Ito yung current temperature value minus yung initial vectors. Tapos, ito yung gagamitin natin to get the temperature one step backward in time. So, gagawin ko, ipapasa ko kay L-curve yung matrix A at saka yung right-hand side vector B. Tapos, gagawin ni Matlab, pupunta ngayon siya kay L-curve. i-execute niya si L curve using the matrix A and the vector B coming from heat diffusion.m. Tapos pag na-run niya na yon, ibabalik niya sa ating output ay alpha temp, which is basically the optimal alpha, and x alpha, the solution coming from the optimal alpha. Tapos, nilagay ko lang to para i-save ni Matlab yung alpha temp, yung best alpha on the jth run sa vector alpha. Kasi gusto kong tingnan ano yung mga alphas na na-compute ko sa bawat time step. So kasi dito paulit-ulit lang siyang sinesave sa alpha temp. So para ma-save ko yung alpha temp o yung best alpha sa bawat j, nagawa ko ng vector name alpha, tapos ang jth entry niya ay yung alpha temp. Kasi pag bumalik na naman tong for loop, nag-run na naman yung for loop, nag-call na naman ako ng line 150, matatabunan na yung previous value ni alpha temp nung bagong result mula sa L curve. Alright? Kaya kailangan ko siyang i-define that way. At kung i-run nyo to, sorry, overtime na, pero hindi ko natatapusin yung run, pero I'll hit F5. Sana mas mabilis kasi 10 by 10 lang naman dito yung matrix A. Kasi remember, ito yung heat diffusion process. Okay, there we go. Tapos pipili na ako ng alpha. But this is for the first run. Kasi di ba meron tayong data na temperature at time j plus 1. So itong L curve na to ay para ma-reconstruct natin yung temperature at j equals n minus 1. So, halimbawa, ito yung alpha kung pipiliin. I'll click on it. Tapos i-confirm yan by one figure. Come on, one figure. Figure number 2. Nagtagal na naman si figure number 2. I don't know what is it doing. Tingnan, inaccurate nga yung aking pagkakaklik kasi wala akong point na tinamaan. Okay, there we go. What happened to figure 3? Okay, so yun yung tinamaan ko. Tapos si figure 3, it was another run of the L curve kasi naka-for loop nga to, no? And makikita nyo dito sa command window, ang napili ko kanina sa L curve, ang bigay sa aking residual error ay 2.47%. And then yung solution norm ay 4.18%. Sorry, not 4.18, but 4.18 times 10 to the negative 1. Tapos magra-run na naman ng isa pang beses yung L curve. Kasi nasa loob nga siya ng for loop. Pero ang problema ko, hindi nag-load yung figure 3. At hindi ko siya ma-open. Hold on. Hindi bakit kaya hindi siya hindi lumabas yung figure 3? But anyway, there should be an L curve here. Tapos i-click ko siya para mag-run uli siya ng isa pang beses. But what I want to illustrate here is the use of an external code of an external function. Ito nga, nagreklamo na siya. Ba't siya nagreklamo? Line 37? Ba't siya nagreklamo sa line 37? Size ng A transpose times A transpose times B. Oh, I don't know what happened there. Nagreklamo siya dun sa second run, pero kanina hindi naman. Pero sige, I'll double check this once again. Pero kanina dire-diretso ka siya nagamit. Pero I hope here you see the ease of using an external function. All right. So that's essentially the point of all of this exercise. So what I'll do is to double check this code. Bakit ayaw niyang gumana? I don't know what happened here, pero dapat gumagana siya. Alright, kasi napagana ko na to kanina. I'll double check and I'll let you know when it's ready, when it is uploaded. Tapos hindi ko na na-discuss yung homework natin, pero what should I do? What I want you to do in the homework is to prove na hindi talaga nagko-converge yung L-curve method. Hindi pala i-prove na hindi nagko-converge yung L-curve method. Pero mag-try tayo ng iba't ibang alpha para dun sa regularized solution. Kasi sabi ni Siltanen, hindi nga daw magko-converge yung L-curve. Nira niya yung different possible L-curves, paulit-ulit para dun sa convolution process at saka para dun sa heat diffusion. Hindi talaga nag-converge yung L-curve method. Kaya gusto ko sana ipagawa sa inyo ay magbigay kayo ng ilang mga alpha, siguro 10 alphas, tapos tingnan natin yung reconstruction. Ilang beses nagkaroon ng stable steps yung ating backward heat diffusion. Right? But I want to talk to you a little more about it, okay? Para mas klaro na, para hindi ko na-explain dun sa mismong homework yung instruction. So, ibig sabihin, madi-defer na naman yung ating yung ating last homework, which I guess is still good because you need to watch the recording pa if you haven't done so, and then submit your reaction video podcast or reaction paper to those 2 videos right before midnight on Monday, right? Monday, 11:59 p.m. para dire-diretso tayo ng discussion on Tuesday. Tapos siguro first 30 minutes sa Tuesday ay ikukwento ko yung ating homework, yung last homework for the semester para hindi kayo mahirapang magbasa ng instructions na isusulat ko. Kasi kung ibibigay ko na yung homework ngayon, mahaba yung instruction kasi hindi ko siya naikwento sa inyo today, which supposedly I should have done today. So, yun na lang. So, madi-defer na naman yung pagbibigay ko ng homework sa first 30 minutes sa Tuesday. Okay? Tapos ang deadline niya, siguro gawin nating Friday, week after next. Okay lang ba yun? And then we'll be talking about singular value decompositions next week, and then probably one more meeting week after next. And then after that, we're done. The rest of the semester will be devoted for the problem set and the actual project, right? So let me close this up. Ayan, nagka-homework pa ako. Hindi ko alam kung bakit hindi gumana yung L-curve ko ngayon. Gumagana na yan kanina eh. Pero anyway, it is what it is. So yeah. Do you have any questions, guys? Or concerns? Yung Morozov pala, hindi ko na rin ikwento. Pero na-upload ko na yung Morozov. I'll probably walk you through it na lang before we do the problem set. Kasi I want you to work with the Morozov routine. So for now, para medyo focus tayo. So for until Monday, focus on the videos that I ask you to watch about singular values. And then on Tuesday, I'll start with discussing with you the last homework. All right. Tapos sisimulan ko rin na yung singular value. And on the side, you can work on the final homework. And then after we discuss singular value decomposition, I'll give you some hints about the last problem set. Okay. And that might include the use of the Morozov external function that I already shared under the regularization module. Okay. Is that okay, guys? Okay, so sorry, overtime na ako ng 4 minutes, so I won't hold you any longer. So thank you guys for joining me today. Enjoy the weekend. Tas kita-kita ulit tayo sa Tuesday. All right? Bye, guys.